In this lecture, I am going to look at how we can determine equilibrium price in the Leontief input-output analysis. At first, we are going to determine unit price. Okay, so I am taking two industry, industry 1 and industry 2, and P1 represent price for industry 1. Okay, and suppose input requirement is given. Let me write the technology matrix first. So I have industry 1, 2. Okay, so this is, let me write it first. Okay, this is the amount of output of first industry used by first industry in order to produce 1 unit of output of first industry. Okay, and this is the amount of output of second industry used by first industry in order to produce 1 unit of output of first industry. So these are input requirement. Okay, and this is basically the technology matrix we have. One factor of production I am adding here is neighbor. Okay, this is the unit requirement of neighbor by industry 1, and this is the unit requirement of neighbor by industry 2. Okay, and I want to determine the price of industry 1 P1 and price of industry 2. So let's determine that one. Okay, so at first let me determine the price of industry 1. Okay, so this is the unit requirement of industry 1 output in order to produce 1 unit of industry 1 output. Okay, A11 represent unit requirement of industry 1 output in order to produce 1 unit of output of industry 1, and the price of industry 1 we have taken to be P1. Okay, then in order to produce 1 unit of output of industry 1, okay, I require certain output of industry 2 also, right? This is the unit requirement of industry 2 output by industry 1. This is the correction that I am talking about. Okay, this is the unit requirement of industry 2 output by industry 1 in order to produce 1 unit of output of industry 1, because we are determining the price of industry 1, right? So here we will write A21, and price of industry 2 is given P2. Because if you remember the assumption that we have taken in the Leontief input-output analysis, that there is a perfect competition. Okay, in perfect competition both industry are price taker, so P1 and P2 is given. Okay, then this is a unit requirement of neighbor in order to produce 1 unit of output of, say, industry 1. Okay, so this is AN1, and suppose wage is given because we are in perfect competition. In this way we determine price of industry 1. Okay, similarly we will determine the price of industry 2. Okay, so we require A12 P1. What is this? This is the amount of output of first industry used by second industry in order to produce 1 unit of output of second industry. Okay, so this is unit requirement of output of first industry by second industry in order to produce 1 unit of output of second industry, multiplied by price of that first industry, of course, because we are using the input of first industry as output. We are using the output of first industry as input. Okay, then A22 P2. Okay, this is a unit requirement of industry 2 output by industry 2 in order to produce 1 unit of output of industry 2, multiplied by price of second industry. Then we will write the neighbor requirement. Okay, neighbor requirement is AN2 into W. Interpretation will remain the same. Okay, this is what we have. Okay, let's see how we can solve this problem. Okay, so take the price term one side. Okay, and keep the value term of the unit neighbor requirement one side. Okay, I take this that side, so it will be 1 minus A11 into P1. This will be minus A21 P2 equal to AN1 into W, and this will be minus A12 P1. Then this term will go there, and it will be plus 1 minus A22 P2 equal to AN2 into W. Okay, this term we get it, and if we write this term here, what we are getting it? We are getting it 1 minus A11 minus A21 minus A12 and 1 minus A22. Okay. Then here you will be having P1, P2, price factor or matrix, whatever you want to say. And here I will be having AN1 into W, AN2 into W. Okay. This is what we have derived from here. Okay. I have written this in matrix form, of course. This one I have written in matrix form. In matrix form, it will look like this. Now, if you remember I minus A matrix, okay, what is I minus A matrix? This we use to sum when we want to take out the gross output. Okay, I minus A will be the, here you have, let me write directly. Okay, I is your identity matrix. Okay, and I am taking 2 by 2. I am looking at this one. Okay, so this will be 1 minus A11. Then 1 0 0 will be minus A12, 1 0 0 1 minus A21, and this will be 1 minus A22. Okay. Now compare these two matrices. Okay. I have 1 minus A11, right? 1 minus A11. Here I am having minus A21. Here I am having minus A12. Okay. So here I have a difference between these two. This is what? This is a transpose of this matrix. Okay. If I take the transpose of I minus A matrix, transpose, what I will get? Row will become column. Okay. And column will become row, whatever you want to say. 1 minus A11, this will come here, minus A12, and this will be minus A21, and this will be 1 minus A22. Look at this one. Both are same. Okay. So this matrix is my I minus A transpose. Okay. So this is the correction I am talking about. Okay. Multiply by price factor equal to AN1 into W, AN2 into W. Okay. This is what correction I am talking about. Okay. Here I am writing transpose. Let me rub this one. So I pre-multiply both sides by I minus A inverse transpose. Okay. So price will be equal to I minus A inverse transpose into AN1 into W, AN2 into W. Okay. Because you know A into A inverse or A inverse into A equal to identity matrix. So here we will get the identity matrix if we pre-multiply by I minus A inverse. Okay, I minus A inverse transpose, of course. Inverse sign, is inverse sign. So what will be the solution for this price vector or matrix? It will be 1 over determinant of I minus A, okay, into adjoint of I minus A transpose. Okay, so this is the solution that we will be having, and I will multiply by AN1 into W, AN2 into W. Okay. Clear? So let me finish the example that we have done in the class and sum for equilibrium price. So this we will get the equilibrium price P1, P2. Okay. So this is the formula that we have to place. Here we have to place transpose. Okay. Because this is the correct way to do it. Okay. Let me finish the same example that we have used. Okay. We have taken steel cone neighbor, okay, and then you have steel cone demand is given here 0.4, 0.4, 0.1, 0.7, 0.6, 5, 2. Okay, this is the unit neighbor requirement. Okay, so in order to produce say 1 ton of steel, you require 5 units of neighbor. In order to produce 1 ton of cone, you require 2 units of neighbor. Okay, so these are unit requirement. Okay, demand, external demand is given 50, 100. Okay, so we have to take the adjoint of I minus A transpose. Okay, Next sum for this one. First I will take out I minus A, okay, matrix. So I minus A matrix will be it will be 0.6 minus 0.1, 1 0 0, then 0 will be here, so 0 minus 0.7 is minus 0.7, 1 minus 0.6 is 0.4. Okay, I will take the determinant of this one. Okay, determinant of I minus A, because I will place here I minus A determinant is 0.24 minus 0.07. Okay, this will be 0.17. This is the determinant I have got. Okay, I will take out the adjoint of I minus A and adjoint of I minus A, then I will take the transpose. Okay, so adjoint of I minus A. I will tell you how to check also this one. Okay, so it will be easier for you. Adjoint of I minus A will be, let me check recording one more. So principal diagonal element will change position and reverse principal diagonal element will change sign. Okay, so it will be 0.4, 0.6, this will be 0.1 and 0.7. Okay, so this is we have adjoint of I minus A. We have to take the transpose and place it here. Okay, so I am dubbing this part and doing this this part here. So price will be 1 over 0.17. Okay, determinant of I minus A I have written. Adjoint of I minus A. Okay, so I am writing the transpose of this one. So this will be row will become column, so it will become 0.4, 0.1, 0.7 and 0.6. Okay, wage is given in this example. Let me check 10. Okay, it is given in the question that wage is 10. Okay, so wage is 10, and in order to produce steel, okay, in order to produce 1 unit of steel required 5 units of labor. Okay, so per unit labor cost is 50. Oh sorry, in order to produce 1 unit of output, you have to pay this much of wage. Okay, to 5 units of labor, and here it will be 20. Okay, let's sum this one what we are getting. So we will be getting 1 over 0.17. This will be 20 plus 40. Let me check here. Yeah, 34. 34, and this will be 5 plus 12, 70. So this I will be getting 70. Yeah, correct. Okay, so take this inside. Okay, you will be getting 200 and you will be getting 100. So this is the price you are getting. P1, P2, you are getting 200 and 100. So P1 equilibrium price is 200 and P2 equilibrium price is 100. Okay, let me check whether this answer is correct or not. Okay, so we know the equation of price. Net place this in the equation of price. Okay, we know that A11 P1 plus A21 P2 plus AN1 into wage equal to P1, and P1 we know is 200. Okay, what is A11? It is 0.4. 0.4 into 200 plus A21. A21 is 0.7. P2 is 100, and this we know is 50. This is 50. This will be 70, and this will be 80. Okay, 80 plus 70 plus 50. This will be 150 plus 50, 200. Okay, so this will be the equilibrium price. I hope this solution will be helpful to you people. Let's do one more question. Okay, so that it can get clear to you people what we are doing. Oh. So next I am doing a question of Calcutta University. Okay. So technology matrix is given 0.3. You have industry 1, 2, 1, 2. Okay. 0.3, 0.2, 0.5. Okay. And the neighbor requirement is given as 4, 6. And wage is given exogenously. Okay. To be 10. Now you have to derive equilibrium price. Okay. This is the question that you have. So equilibrium price formula is, should remember, you don't need to derive every time. Okay. Price is what? I minus A inverse transpose into this is unit requirement of labor by first industry into wage, unit requirement of labor by second industry into wage. Okay, so we can finish in this formula. Okay, so first I will be taking out I minus A matrix. I minus A will be 1. This is 1001, and this is this matrix, this part. Okay, this part. This will be 0.7 minus 0.3 minus 0.2, and this will be 1 minus 0.5 is 0.5. Okay. So I have to take out the, because here I am getting the determinant also we have to take out. Okay. So I minus A determinant will be 0.35 minus 0.6 equal to 0.29. Okay. So I minus A determinant we have been getting 0.29. Now I have to take out the adjoint of I minus A. Okay. So reverse the principal diagonal elements and change the sign of the other elements. Okay. So this will be 0.3, 0.2. Okay. Now I finish in this formula. So equilibrium price will be equal to, this is price vector. Okay. 1 over 0.29. And here I have to take the transpose of this one. If you remember the formula, okay, this is 0.5, 0.3, 0.2, and this will be 0.7. Okay, and we know A and 1 is 4, wage is 10, so it will be 40. Okay, and 2 is 6, wage is 10 is 60. Okay, next sum for this one. Now, price will be equal to 1 over 0.29. This will be 20 plus 12, 32, 12 plus 42, 54. Let me check. 12, 7, 35, 42 plus 12, 54. Let me check for the solution. Okay. So I'm getting 32 divided by 0.29 will be 110.345. Okay, then I am having 54 divided by 0.29 will be 186.21 207 207. Okay, let me check the answer. 110.34 and okay, is correct. We get the answer. Let me finish in the price one. Okay, this is P1, P2. Okay, if you remember the formula, A11 into P1 plus A21 P2 plus AN1 into wage equal to P1. P1 is 110.345. Okay, A11 you know 0.3 and P1 is 110.345. So this will give us, let me check, 110. Okay, let me write it first. Plus A21 is 0.2. Price is 186.207. Okay, and this is 40. It should add up to 110.34. Okay, so 110.345 into 0.3. So this you will get 33.1035. Okay, plus I am adding it. Okay, directly. Okay, let me write it first. 0.2 into 186.207. This will be 37.241 plus 40. Okay, so let me add 33.1035 plus 40. So you will get 110.345. Okay, so this is the way you will take out equilibrium price in the Leontief input output matrix. I hope this video will help you people. Okay, thank you everyone.